Good evening and welcome to our April Jam event. So we've been running these events online for a year. In fact, it was April 2020 when we held our first Jam online, and back July 2012, I think, when we held our very first physical Jam. That seems like such a long time ago. So every month we have a theme, and the theme this month is, how does your garden grow? And it was suggested to us that that's what we do, so that we have a theme each month where, and people said, oh, April's usually the time of the year when people are thinking about their gardens and all that. So that's the theme for this evening. So I'm going to give you a little bit of an introduction to what we've got planned for this evening and what we've got further ahead. And then in a few moments, we will have Nadine, who is our first presenter. We did have another person down to present, but unfortunately they've had to withdraw. So good evening, people on YouTube who are watching the live stream. And I'm just going, one thing you won't know is I'm just going to send Jay off to the green room where he can go and set up his tech, because he's going to be joining us a little bit later on. Now, I do want to show you a couple of things just before we start. So as I've just said, welcome to tonight's Jam. It has a gardening theme, and you might have noticed if you joined us just a few minutes ago, I was sharing something. Now you'll probably notice a few delays tonight, more than normal, because we normally have a team of people here running around in the background that can help us with everything. And some of those have not been able to join us this evening. So thanks to Gary and Josh, who stepped in to try to make sure that we keep things running as smoothly as possible. So I've just done a screen share. There's a couple of things I just want to show you, just in case you weren't already ready. These are just some of the admin elements. Every month, we hold this on a Monday. We used to always do it on the first Monday of the month, but sometimes there's bank holidays, and it seemed better if we didn't always have it on a bank holiday. That's why we didn't hold it last Monday. So our Eventbrite page, if you ever register for tickets, and I would encourage you to do that, you then get automatically invited. I've been on leave for about a week, so if you only got the invitation today, apologies, I should have sent it out maybe a week or more ago, and then you would have. But some people have signed up for automatic updates, so every time we post an event, they automatically get an invite. And all of them are recorded and they go onto our YouTube channel, and we have a playlist which you can access later on. And on that playlist, you'll see recordings appearing as we go along. A couple of other things I want to show you is there's about 4 or 5 people regularly in our team, and we share a Twitter account, Preston Jam. So you don't have to be a Twitter user or a Twitter follower to make use of this. All you just need to know is at Preston RJam. You could use that. You could type that into your favorite search engine, and that will bring you to this page. And that's one way that we share. We're not very tweety on there. There's probably maybe 2 or 3 tweets a month, but there's information on there about what's coming up and when tickets are released and that sort of thing. So we have a pinned tweet on there, which tells you that we have more than 14 hours of recordings available. And it explains how you can go and watch those through there. Now, here's the reason why I'm showing you, because you can also see the program for this evening. That was a tweet that went out 6 hours ago. And you'll see there, it says Erin is up first, except I've just explained that Erin won't be able to join us, but she will be coming back next month with the same presentation. Now, so in a few moments, all of this waffle that you're getting from me will cease, and we will have Nadine. And each of the people who are presenting tonight, a lot of them have got Twitter handles. So if you look there, you can see next to Nadine in brackets, it says @stilllearning_1. So sometimes what people do is afterwards, rather than clapping, because Nadine won't be able to hear you, they sometimes say, oh, I've just listened to a great presentation from Nadine. And then we'll see how that goes. Now, I've just, messages coming through. Jay's having some technical problems. Okay, so So sometimes that happens. We have a technical rehearsal. So if Jay can't resolve those, it may be that the order, we might get Spencer on a little bit before Jay, and we'll see how that works out. Other things to look out for are, there's a link to a form, and we're always asking for people to come and join us. Next month, Sean Razor, who's a teacher in California, he's bringing some students along who are going to present. We're holding a special theme next month. It's the month of May, and it's Brian May is the theme we've gone with. And so your presentation, if you want to talk about rock music, and I know that Scott has submitted a talk linked to rock music, which is really good, or rocks, or the Queen, or Queen the band, or astrophysics, because you may already know that Dr. Brian May has a PhD in astrophysics. So if you click on that form, you don't have to do it now, but I would encourage you to do it at some point. You'll see it's just a little form. You can see who has already submitted talks. So if you were thinking of doing one on rock guitar, you might want to see who else is doing that. So you can click there and that will show you. We just ask for your name, Twitter handle if you have one. But it also means if you use that form, you can see the other themes that we have coming up over the next few months. So once we've got Brian May out of the way, see what I did then we'll be moving to June. Now, you probably already know, if you're in the UK, that we've got this social distancing lockdown is being eased. And I'm just going to move Jay into the green room again. And from the 21st of June, some people have some travel plans. And you may already have travel plans in place, or maybe for July or afterwards, but what are you doing with your tech? Are you taking your tech on tour with you? What kind of tech do you take? Is it rechargeable tech? Is it something that will help you plan your journey? Is it something like, okay, it's not very related to Raspberry Pis and stuff like this, but I have this mini speaker and I love to take this with me everywhere I go. So I might choose to talk about that at our next event, like why I bought that particular one and how much it cost, and you know, so you could just talk about something related. It doesn't have to be something you've built. It could just be some piece of tech that you like to take with you when you go away to keep you in touch, or so you can follow your itinerary or something like that. And then you can see them highlighted on the screen, July, when we have our jam, the theme, sci-fi July. So maybe you've been building costumes at home, or some kind of weapon with technology in it. It's not a real weapon. It's just like a mock or a replica of one that you might see in a film or something like that. Maybe you've managed to create something using a small Raspberry Pi that enables you to time travel to different dimensions. I don't know. So it could be something that's quite funny, humorous, or it could be something that's highly practical. So, and you know what? Once you've submitted a talk, we don't come round to your door. If you don't present, we don't come around and start hounding you, knocking on your door. If you have to withdraw last minute or whatever, don't worry about it. It's fine. But it's just its expression that you would like to present. So so that form is there. It could be something that you've read in a magazine, something that you've seen on TV, something you heard about recently. And please, we're always looking for new people to come along and present, and you'd be very welcome. And if you wanted to, you could go to our Twitter page and send a message to somebody, and like myself or Simon or Josh or Gary or Martin, who is not so well tonight. So we're sending out our messages of condolence and get well soon and all of those kind of things to Martin. So hope he gets better soon. Consolations, I think, would have been a better word. Okay, so check out our Twitter page later on. And when you do, you will find a link there, as I'm going to show you. As I click on there, it would take you to YouTube. And then on YouTube, if I've got the link right at the moment, you should. Oh, I think it's going to take us to the live event. So we're going to end up with kind of a, yeah. Okay, so normally it takes you to a playlist and then you can see what's going on. Now, in about 2 or 3 minutes, Nadine is going to be presenting. And if you remember, I had a little image on here before, all about putting the washing out. But before we do that, there was something that our Raspberry Jam account tweeted probably about 2 or 3 weeks ago. Let me see. Have I still got that there? Am I going to have to go and find it? Did I save the link? Oh, I've clicked on so many things. No, okay. So I've lost the link. Will I be able to find it again? Oh, all I would need to do is click on tweets and replies, and then maybe I can find a retweet. So this is one of the things about Twitter. Sometimes you can just go back and find things. Okay, let's find it this way. So it's a story that lasts about 2 minutes, and you can go and read the story if you want. So it's the same old story that you may have heard many times about how a group of technically minded individuals were exploring the potential of a low-cost computer. They got together and they decided they were going to set up a club to help others. Well, you know what? Word quickly spread. The group starts to grow and grow in number, and they needed a larger venue. So the group, which then got to 100 people in size, they then went to the university, the local university, where there was a room there. You've probably heard me tell this story lots of times before. And then these meetings would take place regularly. So you'd have people of all ages, backgrounds, and experience levels. They bring along sometimes bareboard computers, all sorts of different tech things that they wanted to show off to others and tell people and discuss things and get support. Some of these projects actually led to commercial products and companies. And in fact, one of the, well, I'd say more than one, but they are seen as the most valuable companies in the world started at an event just like the one I'm talking about. So there was other clubs like this around the country and in other countries, and they also saw the potential in low-cost computers. But I'm not talking about RJam. I'm talking about 1975, before the internet, when this Alan here was just 4 years old. And people didn't really own their own computers because they were not, they were very, very expensive. If I just had a message coming through that Jay will be able to present, that's good news. Okay, so what I'm talking about is known as the Homebrew Computing Club or Computer Club. And there was lots of computer clubs in lots of places. There was a computer club here in Preston where I live. But what was special about the Homebrew one? Well, quite a lot has been written about that particular club because of a few famous people that used to go there. So I could reel off some of the names, but two of the names that stand out in some people's memories. And I'm waiting to see, does anybody type it in the chat? Or have you all fallen asleep listening to Alan telling his old nostalgic stories of old computers? But two of them were called Steve. One was Steve Wozniak and the other called Steve Jobs. And it was at that first meeting where they demonstrated something. Now I have something here. I'm just going to reach under the table just to hold up and show it to you. And I wonder, as I slowly reveal what it is, you may have already seen, you might already know what it is. Anybody who can access a keyboard, type in. Now it's picking up lots of reflections from windows and lights and that in my room. But it's about 350 millimeters that way, 475 the other way. It's got lots of integrated circuits around here. It's got a few great big capacitors here. Nobody's typing anything in the chat. So it's the circuit board or a motherboard for the Apple I computer, which was the very first Apple computer. And they made a number of these, and but they demonstrated one at this Homebrew Computer Club. And from then, whoa, I'm presenting on an Apple computer. People have them in their phones, their iPads, and all of these kind of things. So that started at one of those computer clubs. Now we do have some people tonight attending our event, some of them in the background, helping it all run smoothly, who have also been to an event like the Homebrew Computer Club, but that we call RJam. And we've been doing this for not quite 10 years. I think this is our 9th year of running events like this. Yeah, because we started in Lancashire in 2012. So next year, when we get to 2022, we'll have been doing it for 10 years. Now, the Homebrew Club did go on for just about 10 years. I think it says in that tweet somewhere over there. but eventually it ran out of steam. Why am I telling you all of this? Well, because you are the lifeblood of RJam. So the fact that you come along every month and you tell people about RJam and you submit a proposal to talk, and you know, this is great. So we want to encourage you to keep on coming, and maybe when we get to 2023 and beyond, our club, our own homebrewed computer club that we call RJam will still be running. Yeah, maybe. Anyway, Nadine, are you going to turn on your camera and your microphone? It's time for, yes, for me to mute. So Nadine, you have said tonight you're going to present on, it's nothing to do with plants or soil, and that's fine. What's it about?
Well, it is kind of related to the weather.
So I'm going to turn off my camera and move.
Yeah, so I'll try and explain it a bit more in a minute. Because this is a great introduction into what I was doing. Now, recently it was my mum's birthday, and I wanted to make something for her that would actually be helpful for her. And when I was trying to come up with ideas a couple of weeks ago, the weather was really strangely variable. Well, it was down here where I live. And obviously, because we're Brits, we're always talking about the weather. And it kept on coming up in my mind a lot. And that reminded me of times where mum was picking me up from school, or she's gone out to work, whatever it is. And she's put the washing out, and she'll be driving, and then it starts raining. And then she'll go, oh no, the washing is going to get wet. And so I made a little device that can helpfully give her a bit of a warning, so that whenever she prepares to go out, it can tell her, maybe don't put the washing out, it's going to get wet. So I'm just going to run the program, if I can spell it right, which I can't do at the moment. There we go. So this is the fun part. I've tried to put in a little box to try and keep it a bit more friendly for my mum. So I press this button here. And if it's working for me today, it was working 30 seconds ago. Oh, shut the... All right. I'm just going to talk a bit more. So what I have in that little box is 3 LEDs. A red LED, an orange LED, and a red LED. And so it will pick up some data from this weather app and connect it to. And then it will be able to tell me if it's going to rain in the next couple of days or so. And from there, then it can check whether in the next few hours it's going to rain, or in the next day it's going to rain. And it will show an orange light and say, you should be all right. It's not going to be in the next 4 hours, but you know, it's going to be soon. So if it's only a short trip, you should be fine, but don't go out all day. But if it's going to be now in the next couple of hours, don't go out. It's going to rain, and it's going to show a red light. Here we go. Take 2. So I'm going to press this. Oh, I did it again. Oh, God.
So we can just see your camera at the moment.
So I keep on shutting down the command prompt.
Don't worry.
Instead of closing the window. So you're really hearing me waffle on now. And so yeah, you may have seen the little doodles. I'm not normally the most creative person, so that was me trying to brighten it up a little bit.
And should we see anything other than your camera?
Not at the moment,
No,
sorry.
that's okay, just so we know.
It's basically whenever I go and shut the window down, I will shut the whole tab down. And then that cuts it all off, if that makes sense.
Yeah.
So I can actually see what I'm doing on the camera. Definitely did it right this time. Oh, I'm going to just take it out the box. It'll be easier without that in the way. So here we go. There we go.
So we
The
saw
red
light.
light flashes, finally. And basically that means it's going to rain soon. And when I checked the details it sent me, there's a 23.8% probability that it will rain within the next hour. So in this case, don't put the washing out because if you go out, it's going to rain. So I don't have much more to say on that.
Well, I've just got a couple of questions. Yeah.
Yeah.
So Nadine, am I right in thinking you're in Essex? That's where you're based. Yeah.
Yeah.
You don't get an awful lot of rain in Essex compared to other parts of the country. I don't know if you know that. Did you?
Not particularly. No, not really.
Okay. But it does rain.
Of course.
And that circuit that you showed me, so that looks like a breadboard that you've built it on.
Yeah, it's on a breadboard.
So it's like a plastic block for prototyping circuits. You can build things up quite quickly, test things out. What would happen if water got onto the breadboard? Wouldn't that kind of have an impact?
Well, yeah, it would, but it's not meant to be taken outside.
Oh,
I could definitely think about taking it outside, but I was thinking more of a home device.
sorry, that makes complete sense now because.
Sorry if I wasn't clear enough on that.
No, I was thinking this thing would be out in the garden, but if you had a rain detector out in the garden and you need to look out at it, you might as well just look out the window to see if it's raining. So that makes more sense. So the breadboard that you've made, you can take things out. Like if you've got a red LED and you decide, oh, I want an RGB or a green LED or something like that, you can make those changes.
Yeah, there's lots of ideas of where I want it to go, which is why it's still kind of prototype because I had to do it quite quickly.
Have you ever taken a circuit? Have you ever taken a breadboard circuit to the next stage where you start to make a more permanent or semi-permanent version yet?
Yeah, I was thinking of soldering the LEDs on because it's really a pain trying to balance the breadboard on the edge and it keeps on falling out, which is why I eventually just took it out because it's really difficult to kind of go, balance it all.
So have you ever built a permanent circuit board other than breadboard before? I
have once or twice, but I haven't done it in a long time.
Okay, but because I was going to say is, if just to say you live in a town and it's called X town, we don't have to talk about the name of the place. In these towns, how would you find out? Where would you go? How would you be able to figure out how to make a more permanent circuit board than a breadboard?
My instincts for this example is probably soldering a bit. I guess you could have like printed circuit boards, the sort that Dr. Footlegger started to do.
Right. So you've just mentioned an expert. So we have some experts coming on a little bit later. In fact, he's just mentioned in the chat that he's going to be showing exactly how to do that later on. Okay, so that's really good. Okay. The reason I was, because breadboards are fun, but they're a bit frustrating the way after. Oh, they're great for like quick, plug a few things in, it doesn't work. Oh, do it this way around. Oh, and now it does. But they're not great for use every day. So if you're saying to your mum, here, look, mum, or dad, or uncle, aunt, whoever it is that's going to use it, if you say, they're going to go, oh, I can't use this, it's just, and that's what I was thinking, like when people were talking about this Homebrew computer club, I'm used to just turn up with things like that. People like, whoa. So for you and I, we have like engineer kind of brains. We look at everything, oh, wow, that looks so cool. But for it to become...
definitely why I had this little box. So it would be a little bit friendlier. Look, press this bit here, this bit will light up. And a lot less.
And if there was somewhere
near you, if I touch the one thing, it's all going to collapse and blow up. Or
And if there was somewhere near you that you had access to a 3D printer and you could print a box, and I don't know if there's 3D printers yet, the way you can actually print circuit boards, you could just print the whole thing. Just go Command, don't click Command C, because we know that doesn't work well. But if you did Command P, you could print it all and then, yeah.
That would look cool. Yeah.
Right. Nadine, thank you for joining us. Just mention there is a group that you're part of, because you invited me along to one of your online things recently. Tell me the name of that group again.
Yeah, I'm a member of the Essex DMS. Really fun group of girls who muck around with coding and stuff and meet awesome people like Alan.
Okay, thank you. And you meet like once a month, a couple of times a month, and when restrictions are eased, maybe June or July, you'll start. Is it Southend? Is that where you meet up? Or...
Yeah, I think we're normally in Southend.
Yeah.
I think we are thinking of other places like Basildon and Chelmsford. And yeah, we meet like normally 2 times a week, sometimes more, depending if there's someone that we're going to see that day.
But while you've been meeting online, I came to one of these, and there was people from Scotland. There was 2 sisters there, and they were showing us.
Yeah, since we've gone online.
Yeah.
Well, I myself joined online, but yes, we do have some people from Scotland and Ken and all over the country. So.
Okay. Right. Well, thank you, Nadine.
Don't let that deter you.
Okay. So I think we have Jay coming up next. So I'm going to see if I can move Jay to join us, or because I was told he's ready to present, but I thought he might have joined us by now. So,
all right, I'll go over to the green room.
Okay, thank you.
Bye.
Now, so audience, I've tried to plan this evening's event so that in terms of the agenda, the itinerary, we would have our younger presenters on first and our, let's just say, more experienced presenters towards the end of the jam. I didn't want to say the older ones because some of them might take offense at being referred to as the older ones. So we could really do for Jay to move back into this main room here. And at the moment, I think I'm struggling to get Jay in here. So we may move to the next presenter, which is Spencer, and then we'll figure out why we can't get Jay. We've had a few technical issues with Jay this evening. So Spencer, are you able to come in? And oh, brilliant. Okay.
I'm hiding in the wings, ready to.
Fantastic. Right. Okay. I'll turn my camera and microphone off now. Okay.
Well, thank you for having me back. I think this is probably the 3rd or 4th jam in a row that I've presented at, and I absolutely love presenting at Alan's jams. And I'm just going to start my screen share because all the action is actually going to be on a different screen. And hopefully, Alan, I don't know if you want to just sort of jump in and tell me if you can see my screen share. You should see my desktop.
Yep, perfect.
Oh, fantastic. So I wanted to create a really simple, low-cost watering can that I could be used for seeing if my plants need watering, that I could build at school in my Raspberry Pi club at school, and it has a cost less than £15. That was the deal. So I thought, okay, Raspberry Pi Zero, a little bit too expensive. Raspberry Pi Pico, £3.60. That's exactly what I need. Okay, little OLED display so I can see if it needs watering. Another £3.50. And one of these really sweet little moisture sensors, again, that only cost £2 or £3. So Alan just mentioned 3D printing. I absolutely love 3D printing. So I designed and printed my own 3D printed little watering can for it. And I'm just going to turn it on its side so you can see it. Now, I am a country boy. I'm from Somerset, although I live in Birmingham now, but I am rubbish with flowers. In fact, the only flowers I can work with are these silk ones I bought for my wife. I'm really, really bad with flowers because I always forget to water them. So what I wanted was a little monitor that I could look at and see if my plants need watering. So I got one of these nice little watering sensors, and it gives an analog output. So it gives a number, and the number goes from a really low number up to a higher number, depending on how much water there is in the circuit and how much water there is in the soil. And the Raspberry Pi Pico is really brilliant because it can measure analog values really easily. So that's a value from a really low number up to a really high number. And it can take that analog value and they can use it to turn on the display and show a different reading on the display. So I'm just going to zoom in to my my little watering can just down there on the table. So the Pico is really great. It's, as you know, they are incredibly cheap. You can get one from Pimeroni, £3.60. If you solder your own headers on, nice and easy to do. The little I2C OLED displays, again, 2 for £8, about £4 each from Amazon, nice and cheap. And these little soil detectors, soil moisture kits, again, £4. So nice, easy piece of kit. So building it was actually really simple. The hardest part was actually designing the 3D printed case. And I was doing this during the lockdown time recently, while I was doing remote lessons from home. And of course, when I'm teaching from home, I can't have my 3D printer going. So I had to make sure all my printing was done after school or before school. And I learned a really good lesson about how to print cases, which was, if this shape is really difficult to make a lid for. So in the end, I printed the base, flipped it over 180 degrees, made a mirror image of it, whoops, and then printed it again upside down so I could sandwich them together to make a case. And I want this project to be really accessible. So I've written up a really simple tutorial on my website, which is over at the makercupboard.space. And I've included a little circuit diagram showing how really simple it is to wire up the moisture detector and the OLED display. Les Pounder, we all know Les. Les is a huge kind of member of the community. He has written a really great tutorial at Tom's Hardware on how to use the display. So a great tutorial there on how to use your display with your Raspberry Pi Pico. And what was really nice was I discovered really quickly that you could take these measurements from the moisture sensor, and it gave you a value of somewhere between about 1 and 20,000. So it gave this analog reading between 1 and 20,000. And I knew that my display had 15 lines. So all I had to do was take my display, take this value from 1 to 20,000, divide it by 3,000, divide it into 15 chunks, and I could use that to make my display. Now, there's one kind of thing I had a kind of trial and error for, and unfortunately, a couple of sweet peas were harmed in the making of this project. I needed to know how much water it actually needed. So I had to leave my sweet pea plant, just let it dry out, so I could calibrate my little display so I knew when it needed more water. And then I knew when it had been overwatered. In fact, actually, I did manage to kill one, which was kind of quite good. What was really amazing, this sweet pea plant has been sat on my desk for the last couple of months, getting ready for this little project. And only today, literally only today, I noticed this sweet pea variety. I don't know if you can see it on the camera. Might be able to see it. The variety is actually called Spencer, and it's actually been sat facing at me for the last kind of 2 months. Sweet pea variety Spencer, which I think is just absolutely crazy. So what I'd like to have a go at is, if you want to fund a summer project to try maybe in a co-club, maybe in a little Coder Dojo, or maybe in your own school club, if you go over to the website, download the instructions, download the code for the Pico, and have a go at making your own little homemade watering can. Because these are super cheap, and you can do it for under 15 quid. I think this is a nice little project to do with maybe your co-club or your kind of school clubs in the summer term. And this is now going to be sat there keeping my sweet pea alive over the next couple of weeks. One of the nice features about the moisture detector, as well as having an analog output, it also has a digital output as well, which can be used to control a little watering pump, a relay, used to put maybe in a buzzer or an alarm. So you can have a little buzzer on it that goes off if your plant needs watering. So that's quite a nice little feature as well. So how do your plants grow? Well, with lots of love, lots of care, and lots of watering. And if you want to keep an eye on your watering, how about building your own little Raspberry Pi Pico powered watering can? Alan, back to you. Have you got any questions?
No, that's lovely. And I love that we've helped you discover a variety of flowers named Spencer.
I know, it's brilliant.
Yeah.
I could not believe it.
At the school that I was teaching at last, some people would say that the head teacher there was, like, came across as a very angry kind of head teacher, not the kind of head teacher that you would want to cross. And occasionally, this angry head teacher might come across students who were taller and bigger than he was. And people say, oh, did you see what he did the other day? He went up to, so let's just say Spencer is 6'6". He went up to Spencer and he said, excuse me, Sweet Pea, would you mind just picking? And he used to call Sweet Pea. And so thank you, Spencer, for coming along and sharing that with us. So I have noticed before when we've held our jams in April, they tend to be a little bit more quiet than usual. I don't mean the volume, I mean the amount of people who join us. And I guess this people are thinking of, they've got holidays in mind and they've had time off and they just want to relax and that sort of thing. Jay, are you ready to present now? Because I keep getting messages saying that Jay is ready to present, but so if we can get Jay to present, that would be really good. If not, we will move in a few moments to our next presenter, which is me. And then after me, we then have Paul and we have Andrew. So Jay, interrupt me at any point if you're here. I feel like, is there somebody here with a registration, vehicle registration JAY? Okay, right. Well, I'll just carry on with this until we know, because don't know where Jay is at the moment. So, so these April events can be a little bit quiet now. Oh, and Jay, no, right. So Josh has gone for the nuclear option. He's ended the breakout rooms, and no, I'm not sure what's going to happen with Jay. I think we're just going to have to move on from Jay's presentation for the moment. So I will carry on with the story. So April can be a little bit quiet. Now, that means that tonight our RJamJar session will start a little bit earlier than it normally does. And I want to explain and give you a little bit of context as to why the RJamJar session is something that's worth going to. So, and give you a little bit of context as to why the RJamJar session. Okay, things are going a little bit wonky at the moment. So, okay, things are going a little bit wonky at the moment. So I think in an attempt to oust Jay, Josh decided to close the breakout room. So everybody was in the breakout room. It was like, whoa, oh, we're in the main room. We're in the main room. Okay, so that didn't work. So I'm just going to work on the assumption that Jay isn't going to join us. So we have a RJamJar session afterwards. And I want to talk to you about why the RJamJars are important, linking back to the story I was telling you earlier. So you remember I held up this thing here. Now, I hope you didn't think I said it was an Apple I computer. This is just a cardboard reproduction I've made one evening with some chalks and things like that. And so the Apple I computer. So let's go back to the Homebrew Computer Club, 1975. A very young Steve Wozniak, very passionate about building things in the same way or similar way that Nadine is about building things on breadboards. And then this friend of his called Steve Jobs. And Steve was always looking for opportunities, ways to raise money on things, and, you know, very different kind of individual from Steve Wozniak. But the two of them went along and they presented this idea, and it wasn't actually a massive success when they turned up at the Homebrew Computer Club. And in fact, it apparently, do you want to speak, Gary?
Yes, Jay is ready to come out of the green room, which is that we're having some problems getting him into the main room. If you can pick him up and bring him into the main room, that would be great.
I can't. I don't know why I can't. So the technical problems are just, the only way he could do that is if he leaves and comes back, he'll be in the main room. He won't be in the breakout room.
Right. Well, he has been waiting a very long time, so it would be nice if we could get him in there.
It would be.
As the next presenter.
But I think what he has to do is he has to just basically leave the Zoom,
yeah,
and then come back and join the Zoom. Yeah.
Oh, he's here now.
Oh,
here he is.
Okay. Hello, Jay. We're just seeing a black screen. Your camera isn't on, or your microphone. Yeah, hello, Jay. Oh, we can see your camera now. Your audio sound isn't great.
Okay, so good evening, everyone. My name is Jay, and I'm passionate about robotics and coding, as I sometimes conduct sessions at the RJam at UConn. Today, I made a project based on the microbit, which is based on the gardening. So what I've made here is what I've used is a playground for the microbit, a servo, a wire that connects to the microbit and it goes into the soil. And once I turn it on, it shows the moisture level in the soil, because the wire, which is on pin O, is connected to the soil. So it shows the graph on how much soil there is. I mean, how much moisture there is, sorry. So if I press button A, it will show the moisture level in numbers. So here was 626. So there's 626 level of moisture in the soil. So moisture is basically water, and it helps plants to grow as they need water and sunlight and soil and food too. So if you don't have enough water, the graph will go down, and the servo, which is connected here, will activate, and a sign will pop up saying, "Please water me," because plants need water, and if it doesn't have enough water, then it will soon die. So it will inform the gardener to have more water. So if I take this out, then you can see the sign is going up and down. You can see it says, "Please water me," since I've taken it out. The moisture in the air is very low, so it's showing "water me." And if this was the same in the moisture level in the water, then this is the sign that would show. But that's all of the project. Thank you very much, Alan, for allowing me to present my project, and I'll try and make some more projects. So, thank you.
So, Jay, while you've been presenting, you won't have seen on our live YouTube live stream, some people have been commenting so Claire said this is brilliant. Dr. Footlegger said it's brilliant, and Claire really likes the way that you've done the demonstration as well. So there's some lovely pieces of feedback coming through on the chat, and this is great because this was the message I was going to make just before, which was that when a young Steve Wozniak and Steve Jobs turned up in 1975, some people laughed at what they'd done. They were like, "Oh," and other people thought, "Wow, this is brilliant." So it's all about trying to encourage people of different skill levels. Now, for people who haven't met Jay before, you won't know that Jay is one of our youngest members. I'm not going to say exactly. I think last time I spoke, he was around 8 or 9 years old, and I forget which of the two he was, but he's been coming since he was 5. And he has run workshops at our jams where families have turned up. And if you look on our Twitter page, you'll see videos we've shared from the past where Jay has run workshops, and he has a Twitter account as well, which you can find on there. So if I just finish off a minute or two, the story I was saying before leads into something else. And then we will have our next presentation. We have two following me. We have Dr. Footleg, and then we have Andrew just after me. So myself, I went to a club a little bit like the Homebrew Computer Club, but for me, it was back in 1983 when I just moved to England. And I remember there was all of these adults at the club that I used to go to here in Preston. It was called PACE, and it was originally called Preston Atari Computer Enthusiasts, because basically you had to have an Atari to be a member, and I couldn't afford one of those. I think you had to have a lot of money to own an Atari computer, you know, one of these Atari 400, 800, 1200 and all these kind of things. And I had a ZX81, and I remember when I turned up, some of these grown men laughed at me and they were like, that's not a computer, that's just a toy, that's just like, you can pick it up like a plastic toy. But I think I'm one of those kind of special people who doesn't get upset easily when, you know, in those kind of situations. And I was determined I was going to come back either with an Atari or a project that would stop them. So a friend lent me a machine, a toy called a Big Track, and I tried to find a way to use a breadboard so that the ZX81 could control the Big Track. And I'd love to be able to tell you that I went back the next month and I wiped the floor with them, and their jaws hit the floor, and they were all like, oh, but that didn't really happen because I had to learn what a breadboard was, but it set me off on a journey of discovery. And very rarely did things work the first time, but I was persistent, I stuck at it. And I think that's one of the things with these jams. It's the sort of, somebody's got an idea, somebody started on something, come along and hopefully we'll encourage you and support you. And that is more difficult to do when we're doing these online jams and this kind of thing. And that's why I'm particularly keen to encourage people, even if they are having some technical problems. I think if we were all sat in the room and we could see Jay doing the thing, then you know, it would have been a different kind of experience. So I'm going to wrap this up in the next minute or so, and then we will have Mr. Footleg, Dr. Footleg. So Dr. Footleg, if you want to join, I can just get to the point I was getting to, which is not everybody likes to present. Not everybody likes to stand in front of a camera or sit, talk to an audience. As I said before, those kind of things just kind of roll off my back and I'm not really too worried about them. But some people don't. And that's why we encourage you to come to our RJamJar sessions later on. And in our feedback, and we send a link out for feedback every month, and one person fills it in. It's always the same person, which is great. But we'd like more people to fill in the feedback form. And somebody said last month, it was nice. They found coming to the RJamJar sessions was even better. For one, I don't often go to the RJamJars myself. So they didn't have to listen to me go blah, 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 blah. They could talk to other people. And some people just joined and they kept their camera off, but they liked to listen in to hear what people were talking. So we will be running at least 2 RJamJar rooms after our final talk. So Dr. Footleg is going to give us a talk now in a moment. He's going to say something like, okay, Alan, I'm ready. And then after Dr. Footleg, we will then have Andrew, and then we will run our RJamJars. And I will give more details about how to join. And I would encourage you, you can join the RJamJar straight away after the jam, but then go away, make yourself a coffee, feed the cat, take the dog out for a walk around the block, and then still come back in. You don't have to stay there all evening and it's glued to the screen.
I'm ready if you can hear me.
Fab. Right. Camera off for me and mute.
So my project is about automating some of the sensors from my garden. We've seen some great talks tonight measuring moisture levels. Something that's particularly of interest to us at the moment, having a lot of plants outdoors, is the temperature. And I have been looking into options for building temperature sensors which can send the temperature from the garden into the house so that we can keep an eye on how cold is it getting, not just outside, but in the greenhouse, and how cold is the soil getting. And if we've covered some plants up to try and protect them, then what temperature is it under that cover? And you can quickly imagine that with lots of things you want to measure, you could end up needing quite a lot of sensors. So I came across this microcontroller board, which hopefully you can see on my camera. Tiny little thing, and it has that you can see on the PCB at this end. There's like a wiggly trace, sort of zigzag line. That's a Wi-Fi antenna, and this board is a microcontroller like the sort of chip you have on a microbit, with Wi-Fi, which means that it can send messages over my Wi-Fi network as long as it's in range. And so I set about learning how to use these. So let me show you with a screen share what we're dealing with. So this is the inside of our polytunnel a few weeks ago. All of these plants have got substantially bigger since I took this picture. And this is one of the locations that we want to get temperature readings from. We also have some plants in the conservatory, which are looked after by our guard cat. And this picture was taken just about an hour ago, where we've wrapped everything in bubble wrap because tonight's weather forecast is for quite a hard frost. And these tender plants, if they get the leaves frozen, will all be dead in the morning. So we've wrapped everything in bubble wrap, but we don't actually know how cold is it going to get in there because we haven't yet put the sensors out. And this is one of the bits of the garden outside the polytunnel, where again, we've wrapped some tender plants up with some fleece and some plastic sheeting, which will hopefully keep them just warm enough overnight that they'll survive. Although some of them under there are already looking a little bit poorly from the frost that we had earlier in the week. So why choose these boards? Well, they cost 75p each. So they really are cheap as chips. And they're very basic. There's two chips you can see on there. There's the chip that's actually the kind of programmable chip, the microcontroller chip. And this chip is a bit of memory so that you can put your program into memory. And that's really just about it. I've ordered several of these modules and they're not all the same. As you can see, there's kind of components in slightly different positions. I think the two on the right are identical apart from their color. The one on the left has a different number of LEDs. These two, I think, have an LED showing when the power's on and a second LED showing whether there's data being transmitted over Wi-Fi. This one has an LED that's connected to one of the outputs. And so when that pin is turned on, the LED comes on. And when I looked into how do you program these, it turned out to be a lot more complicated than I first thought, because unlike a typical board like the Pico or an Arduino, when you plug these, well, first of all, they haven't got a USB port, they've just got 8 pins, but they haven't actually got a USB protocol chip on them. So you need to actually plug them into something to program them. Now, I don't know if my camera is, let me just stop the screen share, because otherwise I think I can work out how to stop the screen share now I've started it. That's hopefully made my camera a lot bigger. This is a board you can buy that these modules plug onto. So the module plugs onto the header and you plug it into USB port. And that's supposed to be everything you need to program them. But I could not get this board to work, try as I might. It's got a switch to switch between programming and kind of running mode. But no matter what I try, I cannot get the module to program with that board. And it turns out that to program these, you first of all have to boot them up in programming mode, which means that one of the pins has to be connected to the power rail when you power on the module. And the other thing is that you need to actually toggle the reset, it seems, to trigger it to actually do that reboot into programming mode. So I looked around on the internet and I share my pictures again. I came across a way of sneakily using the, this is an Arduino Uno clone, this orange board. And the main chip you see on there is the kind of the microcontroller on the Uno board. But you also have this secondary chip, which is the USB kind of to serial converter, which enables you to connect your Arduino to your computer, so that when you plug it in, you can just say program, and the Arduino IDE sends the program across. And it turns out that you can actually piggyback on this chip, and instead of programming the chip on the board, you can tap off the serial lines, which are these two pins, 1 and 0 and 1 here, the ones that say RX and TX. And you can program, you can pipe them into the module. So this was the breadboard circuit I built. And there's quite a lot going on here. The first thing is that these modules run off 3.3 volts. And if you connect them to more than 3.3 volts, then you destroy them. So they may be cheap, but they're also very easy to destroy. They are absolutely not 5 volt tolerant. So the first thing I've got is, you can't really see it in the breadboard very clearly here, but I've got a voltage regulator that takes the 5 volts, which is this red wire, off the Arduino, and it converts it down to 3.5 volts, which I then tap off with this orange wire. So my power rail here is a lower voltage suitable for my module. The next thing I've got is a reset button, because I need to reset the module to get it into boot into programming mode. And I've got a button connected to the pin that toggles between programming mode and run mode. So you have to do this kind of two button push, where you press reset, you hold down the programming button, and then you release reset. And if you're lucky, it starts programming. If you're not, then you try again, and sometimes it takes 2 or 3 attempts. But having proved that it worked in theory on breadboard, and the actual real thing has, I don't know if you can see in my camera very clearly, but the module is attached with kind of 8 wires. It's really fiddly to plug on and remove. And I decided that what I really wanted to do was make a more robust version of this. So enter.
We had a question. Just explain what tap off is, please.
Right, by tap off, I just mean to kind of take, so the Arduino board here is running off USB. You can't see the USB lead, it's just out of the picture, but it's plugged into my computer, and it gets its power from the computer as well as doing its communication over the USB. But the USB runs at 5 volts, and I want power for my breadboard circuit. So what I've done is I've just plugged into the 5 volt pin on the Arduino, and I've taken the power over to my circuit. So by tapping off, I mean I've just tapped into this circuit to borrow power from it to power my breadboard circuit. So I set about making a proper Arduino shield, and I'm using the old school technique. Instead of getting a PCB made in China, which is a great way of kind of learning about electronics design, but there's a lot involved, and more crucially in this case, it takes maybe 3 or 4 weeks for your PCBs to kind of come back to you. I dug out some of this strip board, worked out which tracks I needed to cut, and I've got a track cutting tool that my father gave me in about 1986, and still gets used today, to cut the tracks. And I then soldered up my strip board. My little voltage regulator, this is actually a surface mount device designed to be soldered flat onto a PCB, but its pin spacing is just perfect to go across the strip board, and they're really easy to solder on the strip board. Even though they're surface mount, you just kind of hold them in place and solder them like you would anything else. So that's providing my power regulation from 5 volts, which is on this bottom line, down to 3.5 volts on this middle line. And then I had one other slight problem, is that in order to put these pin headers on the bottom, I had to solder them onto the copper side. And how do you get the soldering iron in between the header and the pins without melting the plastic? And I decided to use, I've just recently bought this prototyping solder paste which is a very low temperature melting paste, and you just got to squirt a bit off like kind of grey toothpaste. And then in this case, I heated it up with my hot air reflow gun, but it melts at such a low temperature that you could probably do it with a kind of a candle flame or a gas lighter or something, with parental supervision if you're a minor. But it kind of magically just melts and joins everything together. And although it looks like I've smudged it across all the joins, as soon as it starts to melt, it magically snaps onto the copper and disappears off the gaps in between, as you can see there. So that's kind of after applying heat. And here was the result. So I've got now this Arduino shield. It's all the same components that you saw on the breadboard, but it's a nice permanent kind of solid circuit, and I can just plug my module on the top. My buttons are easy to press. You can't see both of them in this picture, but there's the two buttons there, and I'm up and running, able to program my module. So let's have a quick look at some code, which has just gone behind my pictures. There we go. I don't know if that's big enough for you to read, and I don't know if I can zoom in on the Arduino. Let me.
Will you later on have a link to something that people can read online? We'll then include that in the description.
I will, but I haven't yet, because
don't worry.
Yeah, I haven't yet finished publishing the code. I was literally writing this whilst Nadine was talking earlier. But I was listening, Nadine. I did enjoy your talk. If I just save it into a different editor.
And did you say the name of these boards? I know you said they were microcontrollers, but do they have a name?
Yes, that's a good point, Alan. I didn't say what they were.
So you demonstrated earlier, there was a photograph of what looked like an Arduino Uno clone.
Yeah, so the Arduino Uno clone was just think of it as an Arduino Uno. It just wasn't the one made by Arduino, but there's lots of clones available. The modules I'm using are, the actual chip is an ESP8266.
Okay.
Yeah, but there's lots of different boards with that chip on, and these boards are called ESP01.
So some people refer to them as the ESP8266.
So that's the chip that's on the board, but this particular very cheap module that is the board with some memory and a Wi-Fi transmitter is an ESP01.
Okay, that looks quite large. The text easy to read on this screen I'm looking at.
So this is the Arduino environment. So the code is actually C, but it's hopefully not too complicated, and most of it is just importing other people's libraries. So there's a couple of libraries needed for MQTT. If you don't know what MQTT is, it's a message protocol used by Internet of Things, and it enables you to send messages to a server, and you can then listen for those messages. You can subscribe to the channel on the server with your Python code on the Raspberry Pi, or with a Node-RED program, or all sorts of different languages can talk to MQTT. And so the messages that get sent by my device are picked up by anything listening to the channel on the MQTT server. And it's a great way of passing data between devices and between programming languages. So we could do a whole talk on it in its own right. I won't go into it in any more detail tonight. But there's a couple of libraries needed for that. And I literally just took an example of how to do MQTT on these devices, which I found online. And then I'm using these one-wire Dallas temperature modules. I'll show you in a second on the camera when I stop screen sharing what they look like. So I've got a couple of libraries needed to talk to them. Then I need to connect to my Wi-Fi network. So I need to define my Wi-Fi SID and my Wi-Fi password. So I just define those as strings that I can then use in my code. And I also need to talk to my MQTT server. So I need the name of my server and the port that my server's running on. And for MQTT, you send messages to a named topic. So I need to say, which topic am I going to broadcast my messages to? So I've created a topic called garden. So I'm going to send messages, and anyone listening to the garden topic on my server will pick up the messages. So then I'm creating an instance of my ESPP client. That's my Wi-Fi. These are just classes that I'm creating instances of. Think of that, that's a variable, and this is the type of variable. Another variable and its type. So these are just taken straight out of an example. I then need to also define which pin have I connected my temperature module to. I put it on pin 2. And then again, I'm creating another variable, which is my one wire communication. These 2 lines straight out of an example. So I've got all the pieces I need to now start talking. So in my setup, I've opened the serial port so I can debug what's going on over the Arduino serial module and send messages to it. I'm then calling a method called setup Wi-Fi that is down here, but it basically came straight out of an example which I found online. That connects to my Wi-Fi network, so it uses the SID and password that I've programmed at the top. So I'm now connected to Wi-Fi. I've now created an MQTT client connected to my MQTT server and its port. I've sent out a message to the console just saying what my module's doing. That's really helpful, because if that message doesn't appear, I know my code didn't take and my module's not actually talking to me. But if I see that appear in the IDE, I know that my module's up and running. And then I start the sensors from running. So then we'll skip down to the loop. These are the messages in between, functions in between, again, were straight out of the examples, and they're how to send an MQTT message and how to reconnect to the server if I've lost my connection. So all I do here is I request temperatures from my one wire module. I then ask what was the temperature of the first module, because you can put several of these modules on the wire. So it's just getting the temperature from the first one, and then spot the deliberate mistake because I haven't actually run this code yet. I don't want to send 0. I want to send my temperature to my send message function. And then I want to wait because I don't want to spam this thing with temperature readings every 5 seconds. I was, for an example, going to show you it running, but I don't think we've got time to kind of set up a live demo. But I would actually probably want this to wait for maybe 15 minutes, 20 minutes, maybe an hour, just to give me a temperature reading every hour. So what we end up with, if we go back to the camera, is my temperature module looks like this. So this is a one of these. It's called a DS18 N20 temperature module, and it's waterproof, and it's on the end of a cable. This one's on about 1 meter of cable. And cost me about £1 from China. If you really want to push the boat out, you can get one on 3 meters of cable, and that costs about £1.20p. So with that sensor, a 20p voltage regulator chip, I can plug a battery onto my board. I've got at the moment a breadboard circuit. You saw part of it earlier. To kind of connect one of these modules up to the sensor, but you can guess that I'm very quickly going to be doing another very broad circuit. And there's just one more thing I'll show you on the camera before so this is my shield, which I plug my module onto. So my module plugs onto the pin header there. And then when I'm programming it, I just need to hold down the 2 buttons and release reset, and the thing should go into programming mode. So one last thing I want to show on the screen share is a program called Fritzing. And Fritzing is a program for designing visually kind of how things look in the real world, diagrams. And what I've done here is I've dragged into Fritzing an Arduino Uno board and my circuit And then this was the actual kind of shield board that I mounted it all on so that eventually I could plug it straight onto the Arduino. So what we see here is that I'm basically tapping off the power, ground and 5 volts. So the black and red wires are just taking power over to my circuit. The 5 volts is going into the voltage regulator, which converts it to 3.5 volts on here. And then all my components are connected to the 3.5 volts, not to the 5 volts. And I've got my 2 buttons. These resistors are what we call pull up or pull down resistors. So when you've got a pin, like this pin is the reset pin. And the reset pin needs to be connected to either the voltage rail, the 3.5 volts, or to ground, depending on whether you want reset to be active or not. And what you don't want is it for it to be floating free, because your device could randomly reset due to kind of noise in the ether, or you won't know what's going on. So what we do is we've got a button, which in this case connects reset directly to ground. You notice that the button is bridging between reset and ground. So when the button's pressed, the reset pin is shorted to ground. But when the button's released, the reset pin is connected through a resistor to the 3.5 volts. That's called a pull-up. So it means that when there isn't the short with the button pressed, the short circuit that the button makes to ground is not closed, then the pin gets pulled up to 3.5 volts by the resistor. And the reason we use a resistor is that if I didn't have a resistor and I just used a wire link, then when I press the button, I would have a short circuit between 3.5 volts through that link through to ground, which would probably blow up my voltage regulator. So the resistor just stops the power going through between the voltage rail and the ground from being excessive. So it tends to typically be around a 10 kilo ohm resistor, so that it's enough to pull the pin high to a logic state of 1, but it's not enough that when you short circuit the button, that pulls the pin down. And the same thing's happening here with this button, which is doing the same thing for programming mode. And then the other resistors are because I'm pulling the serial signal from the Arduino board. And the Arduino board, remember, is 5 volts. So when I'm talking back to the Arduino board, that's fine. I can just go straight from my module to the board, because I can send 3.5 volts to the 5 volt board and it understands it. But what I don't want is the 5 volt board sending a 5 volt logic signal to my module, because it would blow up my module. So what I do is, if you follow this green line, it actually goes to a resistor, and the resistor is connecting this line down to the reset pin. But there's also another resistor taking that reset that pin to ground. Yeah, so this black line is ground. So what I've got is a voltage divider. I've got 2 resistors, and I'm tapping into the point between the 2 resistors. And that means that I get the middle voltage. So I can take my 5 volts, in this case, down to 3.5, because my resistors are kind of values of that are effectively kind of a ratio that gives me 3.5 volts instead of 5. So that just protects my circuit.
Paul?
Yes.
Just before we move to Andrew's presentation, there's something I'd like to ask. It's partly prompted by discussions on the chat and the live stream. It occurs to me that pretty much everything you're showing so far, in terms of cost, it's either been free or extremely low cost. So some of the components, the boards, we're talking about £1 for this, 70p for the other thing. And some of the software that you've shown, I think it's free. I think Fritzon is free to use.
It's free to use. It's open source, but they've stopped providing a compiled version of it. So you can build it yourself from the source, or you can pay them a kind of an amount of money. I forget how much it is.
But the question,
a Windows installable.
So the question I was building up to was, so in terms of physically getting hold of the things that you're using, the software tools, the components, for a lot of people, there aren't that many barriers if you know where to get these things from. But the comments say, gosh, this looks so complicated and it can be so confusing. But you've been doing this for a good 10, 20 years or so yourself?
So I've been doing electronics. I mean, some of my tools, as I said, I got in 1986. So I have got a lot of kind of electronics experience going back years.
But when you started, you won't have been working on projects of this kind of technical
absolutely
complexity.
not, no. So when I started, I was using things like the Arduino Uno, which could do this job. I mean, it doesn't have Wi-Fi, but there's plenty of options out there now that do have Wi-Fi. One great option, actually, if you want a much simpler route to kind of get programmed modules with Wi-Fi, is there are ESP32 modules. And the ESP32 will cost you a whopping $3.50 US, I think I paid for mine. It's a much more powerful chip, and you can plug it straight into the USB port in your computer and program it through the Arduino interface IDE.
Okay. But I was going to take you back to like almost you in 1986 at that stage. If somebody now is watching this thinking, that I'd love to do things like that, but I don't know where to start. I mean, I know one of your projects was recently shared in the Hackspace magazine, which people can download for free. So where would you suggest that people start in terms of, I want to do things like this? Like, would you say find the Hackspace, see if there's a tutorial in there? Where's a good place to start?
I started with LEDs and resistors. Yeah, the thing that we all love playing with, really, really simple, because it teaches you the basics of you can't just stick any amount of power through a delicate electronic component. Yeah, if you plug an LED onto a battery, chances are the LED will go pop.
So we saw this evening when we started. Nadine was showing us a board that she had with LEDs on.
Yeah.
And we actually talked about, well, what might be next and could you do this? So I suppose if you're thinking LEDs at like an entry level,
yeah,
it either works or it doesn't. And there's a certain amount of fault finding and debugging to, oh, it's because it's polarized, I've put it in the wrong way around, or, oh wait, it went really bright and now I can't get it to light up again.
Yeah.
You know, so you made all those kind of mistakes back a few years ago, which
a few decades ago, let's say.
Yeah, which has given you the confidence to move on to more challenging projects.
Yeah,
it was Eve in the chat who got me thinking about it, because she was saying that, you know, she said she's read electronics can be one of the most difficult subjects due to the ideas and thinking involved.
Yeah, but I'd say the next big topic that really kind of taught me stuff was playing with logic. So we're familiar with it in programming, where you set your pins on your Raspberry Pi or your microbit to be kind of 0 or 1, which is kind of on or off. But when you start playing with the electronics, then you realize that, well, kind of it makes you start thinking, well, what does on and off mean? For an LED, is it got power? Has it not got power? But how much power? And so starting to play with logic and thinking about how I could connect. I used to make LED animation circuits with logic ICs, where I would have, there's a very famous chip called the 555 timer, and it needs about 4 components attaching to it, and you can choose different values of those components to set the clock interval, and it will turn a pin on and off on a cycle. So there's lots of other things you can program it to do, but I would use it as a clock. So it would turn on and off maybe 10 times a second. And I would take that logic signal from that chip and I would put it into another chip, which had 8 outputs. And every time the logic went on and off, a different one of those outputs would turn on. And then I started connecting LEDs up to those outputs. And so I could now flash a sequence of LEDs. This was before programmable chips were a thing.
Imagine when you were doing these, you're in this sort of, like people talk about being in the zone or in flow. You're like so so heavily focused and concentrating on what you're doing. Sometimes the hours might go past and you might even forget to eat sometimes.
Yeah.
Yeah. Okay. Paul, it's been really lovely to have you, or Dr. Footleg, as you know, to have you along here this evening and share some of your projects. And I hope you will join us back for Brian May, Tech on Tour, and Sci-Fi July. I think you've got something that was very popular with people before, the sci-fi related.
I think we could probably bring that out again for.
okay.
I might even be able to make it non-copyright, editing some of the audio so that.
Because was it Nadine that was inspired by that project? I can't remember.
It was Eloise who was building
Eloise,
one
okay,
in the S60 Mets. Yeah.
Okay. Right. We have our final presenter of the evening. Andrew, are you still there, Andrew? You're going to come and join us now. Do I need to move Andrew? I think Andrew popped up before. In fact, if I close the breakout room that we have open, I'm going to do that now. And then everybody who's in the green room will be in the main room here. So, a couple of things to mention. So Andrew's going to do his presentation. It's our final presentation this evening. And then after that, we initiate the breakout rooms where we say to people, come along. So we're going to set up 2 breakout rooms this evening. Josh is going to be the captain of one of those rooms, Josh Lowe, and Gary Lewis-Jones will be our other breakout room captain. And I will maybe mingle around a little bit. And then people in these rooms, they just chat and talk almost like you would if you're in a cafe, sat around a table, in a library, in a pub, somewhere like that. So I don't know if you know. Anyway, Andrew, are you ready to start?
I might be.
Getting there. Okay.
So hopefully you should be seeing gardening with data, which is
and I'm going to turn my camera off now.
So it was also sort of some of the thing we've been talking about is how people got into electronics or new things. So I thought I'd do a project which I knew nothing about basically, and so it's a story about doing something outside your comfort zone, something which isn't your area. And I came across this phrase which was, I can't speak French, but never mind. It's a little flanière, which is sort of going for a bit of a wander, and how going down one project you sort of then going down rabbit holes and you see all different things. So the overall theme is, can you make the garden grow better with data? So people talk about digital transformation and using data and things like that. So the general sort of idea is if the project's on a graph, then on one side you've got the speed that the plants grow at, and the other side you've got conditions, and you have to try and find these relationships between it, and that obviously leads to success and profit because you get nice healthy plants. So I'm kind of got plants. You can work out whether or not the project is a success as to how big you think they are. So in terms of doing this thing of trying to optimize the conditions to grow plants better, you need to work out what the conditions are like. So similar to Jay and similar to Dr. Footleg tonight, started collecting soil moisture information, temperature, humidity. I've also started looking at UV and the colour of light, see whether that makes any difference. So to get all the data, I want to record it. I've got the sensors out in my garden, and I'm using Codebug, the new Codebug, and this is really what it was designed for. So if we look at the code, the whole point that I created the new Codebug was so you could make projects like this. And Dr. Footleg, had to do quite a bit of coding. The idea with Codebug is you can just write, about 8 lines or so, and from that it will read stuff from the sensors, and then it will send it up to a live graph. And so if I then first live demo of the evening, first chance of it going wrong, bring the website up, just clicking away. So you've got this drag and drop, you can stick the code in, you send it over to the Codebug, and then you've got this graph, which is on this one, you've just got air temperature and humidity, and every now and again you should see a new data point fly in, and that's as it sends the data every few seconds over Wi-Fi. We were talking about ESP32, so Codebug has got an ESP32 on it with a few of the chips to give it a bit more memory and a few of the little tricks, looking after the security, things like that. So that was the first part of the project. This isn't really outside my comfort zone. It's something that I've been working on for a while. It's new code, but it's not really been the challenge. I've done this sort of stuff before. So if we go back to presenting, for all this again. So the next part was to work out given we know what the conditions are for the plants, how do the plants respond to that? So for that, I was going to use machine vision, and you point a camera at the plants and then you can measure how well they grow. So I've never really done any machine vision before, but you know, it's not my area, but famous phrase that I use for a lot of projects, and I discovered Pete Lomas had a similar one. It's like, well, how hard can it be? Let's give it a go. So I kind of had a quick look in machine vision, and machine vision, it seems to change. There seems to be a new way of doing it every week or whatever. So the latest way of doing it seems to be you pipe the camera into a framework called OpenCV, you shove it through deep neural networks, which are all the rage, and then from that, OpenCV draws a picture on the screen, and it will also generate the, it will save the data to a file. So that looked like it was a reasonable framework. So it's got this magic thing called a deep neural network. And when I was doing my PhD, we used to joke that if you didn't know how to solve a problem yourself and write about it, then you'd use a neural network because you didn't have a clue how it worked. So I tried to kind of get an idea of a bit more about neural networks. It was new, so I found this quite a nice tool to. I've lost my mouse pointer. To visualize how they work. So on this side here, you can see we've got data which is clustered into two sort of areas. You've got the orange ones in that area and you've got the blue ones in that area. And what you want to do, you want to train this neural network to be able to distinguish between the two different colors. So effectively, you end up with these two, you start off with random weights. So you've got no idea what the neuron's going to be. So you just initialize it with random numbers, and then you run it a few times. And based on whether it's got the right answer or not, you change these weights. So this is partly, you know, you could say it's trial by, you know, programming by trial and error. I'll start writing things, I'll change numbers, and I'll keep changing numbers until it works. So if we click this big play button and run that, you see it's run a few times, and it's got this line down the middle. And so it's worked out that if you've got, it can now split that. So if it's presented with either an orange blob or a blue blob, it can work out where it is, and it's worked out where this division line is. So this is just with two. But if we have data which is distributed in a different way, so in this instance, we've got to try and, we've got the orange blobs on the outside, you've got the blue blobs in the middle, and you want to try and distinguish between the two of them. And we try and run that, you see it kind of hits around there and it comes out with this split line there, and it doesn't really work. So what you can do, you can put more neurons in. So you put more in the middle, we try running that, and you see it's getting better. You've got kind of a region here, but it's still not really doing it because you can't do it with that number of neurons. So basically you can add more layers or more neurons, and ooh, that's sort of nearly working. You've got this thing, but it's not quite on the other side. So let's stick some more neurons in. I think forwarded it. And you can see after it's become stable, and we've got this thing which is now splitting it. And the thing which becomes really obvious about this now is that how the weights have changed, and the thicker the weight, the bigger, the thicker the line, the bigger the weight is. So from the different neurons, you can see that it's really sort of taking different aspects of this function, if you like, which splits things. And it says, right, well, I'll take a bit of that one, I'll take a big bit of that one, and quite a big bit of that one, but not very much of that one, and that will decide for this way, and then that'll do that. So basically, by having this set of neurons and that which start off random, and then you just sort of have this thing called backpropagation, which changes the weights on them, you can build something that makes decisions over things. So you'll also see that it's depended on, you saw it took longer to stabilize when it was more complicated. So it had more trials before it got an answer which, you know, pretty much worked. So that's the theory then, in terms of what we need to do. We need to have something which we can show it a picture, and then it can take that picture and make a decision about it. So I need to start that slideshow. So, general thing in terms of, we talked about how we got into various things. If you don't know how to do something, then solve something simpler first. So the first thing I thought I'd have a look at is, you can't see the cursor, but recognizing digits. So in this case, this is recognizing a number 9. So you can see my quality handwriting there, like very neat. No, it isn't. And then behind that, you've got the 1s and 0s, which represent where there's a line, where there's a 1, or there's a 0 where there isn't one. So you can effectively, you can put a hand-drawn number into a computer. And so you could take these points and you could feed it into a neural network, and you can get something with a training way. You can then make it decide which number it is based on where the ones have been sent in. So the problem is, if you start doing this with a camera, which has got a picture of plants and that, there's too many pixels. If you think about, the Raspberry Pi camera's got about 12 million pixels, and then there's red, green, and blue. So you can multiply that by 3. That's an awful lot of pixels, and you end up with, it just takes too many neurons, and you just can't do the calculation. So the next thing I thought to sort of go back on, in terms of if you've got something that you're not sure about, is look at something where it's
breaking up a bit.
GPS signals, and everything.
Your audio went a bit blurred.
GPS signals, and so the way GPS works is you have a whole series of different signals on top of each other, and you try and find the satellite that you're interested in. So you do that by sliding along the signal that know what it looks like. And when you put images, so if we go to the next slide.
Your audio just went, I think your signal dropped quite a lot then.
All right, are we back?
Not much better. Are you downloading Windows updates at the same time?
No.
Suddenly a very heavy load, I think, has gone on your internet connection.
I like that.
It sounded like it was a bandwidth issue.
My laptop suddenly decided it was running out of power, so I was wondering whether it was going to work.
Okay.
So it was shutting the CPU
That's
down.
perfect.
So, sorry about that. So convolution is basically where you take a shape, you slide it along, you try it for different positions, and each position that you try it at, you multiply with the signal. So if you've got something which perfectly matches, the big lumps will make the big lumps even bigger, and the big lumps on the other side will make them even bigger that way. So you end up with, if it's a perfect match, something really big. If it's a signal which doesn't match, then you'll end up with something which is up and something which is down, and those will cancel out. So you can use convolution to work out when you've got a perfect match. And so that's how you use to decode GPS, something that I knew about. Let's apply it to image processing. So in this instance, we've got the 9. We've encoded it slightly differently. This is taken from an online video that I went through as well. And you have a block, and that block recognizes just a pattern. So in this case, that block in the middle is representing a circle. So the top of the 9, the ring. So that you slide over every single pixel. And then if you multiply the pixel value with that mask value, you'll get an, and then find the sum or the average of that, you'll get a different number which says how well it matches. So the section highlighted in green, you've got a 1 in that because that is a perfect match. If you do it once square to the left, then it's not a very good match, and that's why you get a low number, minus 0.11. You keep sliding that over, and you do that for every single square, and eventually you end up with this matrix. And as you can see, the only place where it really matches well is at the top. And so basically what you need to do image recognition is build a series of different patterns or features, and then those features So it got to learn the features, it's got to learn how they're related, where they are spatially, and then if you shove all the images through, you train it, it sets all the different values through the neural network, and it will give you a confidence as to how well it matches. So that was the theory. And like I say, this is all new to me, so this is not my area. So if anybody doesn't know about image processing, they can probably, correct me or tell me how I should have done it. But part of it was just like, the great thing is just having a go and finding things out online. So first attempt was Raspberry Pi with the Pi camera. It was very slow. So I found that there is something called a neural stick, which I don't think is the best way of doing it, but I had one kicking around, so that was better than one that I didn't have. And that's got hardware accelerator in it. So I'm a hardware person, so if in doubt, just throw more hardware at things. So that's basically got a specialized microprocessor which plugs in to the Raspberry Pi on the USB cable, and it loads into that all the weights, all the different numbers that go into the neural network, and then it just squirts the data out, and then does lots of things in parallel, and then squirts the answer back. So let's go for the second demo of the evening and see whether that works. So I have got, or I should have on my desktop, a Raspberry Pi. I'm just hoping you can see that. So fire up.
See the command line?
The demo. So it takes a few seconds to run, and then the way this is configured is it will should just, oh, that's quite hot. Shows one, how untidy my office is, but also it should give various recognition. So if I now bring up some pictures of plants, except I can't see what, let's move that onto the screen. So you can see it's briefly, I got a green rectangle around where the plant is. All right. You can see the latency is not great. So this is with the hardware acceleration, but you can see that it would be even worse if it didn't have the acceleration. So you can see it's seeing some of those plants there. And so the problem was, let's give it a go. Here's my plant, see if it just catches up. Does it detect the plants? So there's not seeing any boxes. So that was a fail. It detects me mouse, but that's a separate issue. So now I've got soil on the mouse. Get back to the demo. And I suppose part of the story behind this is sometimes it doesn't work, but that doesn't matter. And you learn a lot of things from the process. And so why did it fail? The reason it failed is because these things you have to try it. We're saying, you've got to give it enough examples so it can propagate that data back to set the neurons. And basically, I didn't have enough pictures of plants, of the exact type of plants that I was looking for. But one of these things that I did have in terms of gardening, so finish on a bit of a success, is Dr. Footleg said he got a guard cat. We don't have a guard cat. Next door has a cat, but next door's cat has either thinks it should be a badger or a rabbit, or wants to excavate things, or uses our garden as a toilet. So it's always interesting to see what it's dug up and where the plants have ended up. So one of the things I thought, right, give it a go, is I used it trained with pictures of a cat. I think we might be able to get a cat. we do search for cat. You can see it's really, but it detects cats very well. So you can see it's seen a cat. So from that, I could then, you can see the code firing in the background. It says, right, it's found a cat. So if we go back to finishing off now, it was really, it's an this was a, should give people confidence to try something. So even though they don't know what they're doing, it shouldn't put people off. It didn't put me off.
Useful solution that if it finds a cat in the garden, because not all cats are friendly to all plants, as gardeners will tell you.
Well, this is the problem we have. The cats are, you know, excavators, and that's what I was meaning by, I think they want to be badgers and start digging all the plants up. So that was why I sort of thought I'd bring everything all full circle. So basically what I should have done, I've discovered, I think I should have used transfer learning, and that is where you don't completely try and build this model and train it from scratch. So it has to work out what all the different patterns are. You get something where it can vaguely detect things, and then you just change it subtly. So it learns just the features of what the particular type of plant I've got, what they look like. So that's what I'm going to try now. I also saw that there's a blog post in Raspberry Pi today about Edge Impulse framework for helping to do these sort of things. So I might try that.
So Andrew, will you be joining our RJamJar session, which is going to start soon?
Yes, I assume you're buying.
So yeah, and then people can direct some of the more technical